please report to room A9.
Hi guys, I'm still here. Today we should be going over the module Caesar's Maths. So basically we're given a maths equation encrypted in Caesar cipher with all the spaces removed as well. And we just have to select which of these answers at the bottom is the answer to this equation. So first let's calculate our Caesar shift using this formula. So we're starting with 6 times the sum of the digits in the serial number, which is 1. Then we're going to be multiplying this by the entire quantity of number of batteries on the bottom plus 3. So we have 1, 2, 3, 4, 5, 6, plus 3 is 9. Raised to the power of the number of green LEDs on the module. We don't have any, so it's 0. And then we should be subtracting off the number of LEDs, which is 1, and then lowering this entire thing by 26. Which gives us 5. So our Caesar shift is 5. Now we come down to this table here. Our shift key is 5. The top row used shows the encrypted letter, so we're going to use the column of the encrypted letter to decrypt that letter. So we have R, which becomes M. We have Z, which becomes U. And the first word is generally a command word of add, subtract, multiply, divide. So it's going to be MU, and the Q would probably translate to L, yes. We can assume this is multiply.
Emergency cleared. All personnel, please return to your stations.
So MULTIPLY. So starting from here, J, E, Q is L. I'm assuming this is probably 11, just because we have J again. A is V, so 11 is probably what this is. So ELEVEN. So starting from here, this is probably going to be AND. So it's going to be BY then. G and then D. By. X, which is S. N, which is I. C, which is X. Y, which is T. Double J is EE. And then S is N. So our question is, multiply 11 by 16. There's only one answer here that it can really be. Because this isn't... Neither of these are actually multiples of 11 or 16. Only this one, so let's just check. 11 times 16, 176. So press the button. We get self-module. So as you can see, you don't have to figure out the entire word. And of course, some of you might say, why don't you just use crypty? Sure, crypty makes it so you don't have to find your Caesar shift. So sure, I'm going to do one example using just typing this into crypty. Or will I? No. That just defeats the module. So let's just do another one by clicking our Caesar shift key again. I just want to acknowledge you can use crypty, and it's not it is like looked down upon as of not doing it properly, but crypty is allowed in challenge bombs, so just do note that you can just use crypty to Caesar shift this. I think. You might have to confirm that. Okay, so the digit serial number is still 1. pressure volume is still 9. Number of green LEDs is still 0. And number of red LEDs is still 1. So, funny enough, our shift is 5 again. So, X becomes S, Z becomes U. This is probably subtract. So starting from SUB TRACT, KNKY, F I F T. We can assume this is probably either 50 or 15. So to look at D, we get Y, so this is another number, so we can press space. So carrying on, F W T, this is probably from. So subtract 50 from R Y becomes M. So this is the M, so T. M becomes H. N becomes I. W becomes R. T. 30. F. This is going to be 4 or 5. This could be 5. You can see here. Subtract 50 from 35. Wait, subtract 50 from 35. I think this means 50 minus 35 rather than 35 minus 50, which is 15, because the other way around would just be negative 15. Press 15. We're self-module. So as I was saying, of course you could have just used KTaNE, so I'm just going to show off that if we stick this into KTaNE, then go back by 5, sorry, forwards by 5, this was the string we had. So, of course, you would subtract and you'll get this, and then you could just work it out from there. But hopefully you understand how Caesar's maths works. Let's see you guys in the next tutorial.